Imagine relying on critical measurements, like those from medical devices or industrial control systems. What happens if those readings slowly start to become unreliable over time? Sensor drift correction is an essential part of calibration because it ensures the continued accuracy and reliability of sensor readings over their entire operational lifespan. Without it, even a perfectly calibrated sensor will eventually provide incorrect data. Sensors, regardless of their initial precision, are physical devices susceptible to subtle changes over time and exposure. Factors like material aging, sustained thermal stress, mechanical fatigue, chemical exposure, and even varying environmental humidity can gradually alter a sensor's fundamental characteristics. This slow, often unnoticeable shift in output for a constant input is precisely what we refer to as sensor drift. Calibration, by definition, establishes a known and accurate relationship between the sensor's input and its output at a specific moment. Drift then causes this established relationship to slowly deviate from its original, accurate state. Therefore, periodic recalibration, which inherently includes the identification and correction for any observed drift, is absolutely necessary. This process maintains metrological traceability and ensures the sensor's output consistently remains within its specified accuracy limits, preventing the accumulation of errors that are not sudden but rather a slow, persistent degradation. Practically, managing sensor drift involves establishing a regular recalibration schedule for each individual sensor. This schedule is typically determined by the sensor type itself, the severity of its operating environment, and the specific accuracy requirements of the application. During the recalibration process, the sensor's current output is meticulously compared against known, highly stable reference standards. Any observed deviation, which signifies drift, is then precisely quantified. This deviation is subsequently compensated for, either by adjusting the sensor's internal electronic parameters or by applying a software-based correction factor within the larger system that interprets its readings. This proactive and systematic approach effectively prevents the uncontrolled accumulation of measurement error. Understanding and actively managing sensor drift is a cornerstone for ensuring the long-term stability and trustworthiness of any measurement system. This critical concept is also vital for maintaining what is known as metrological traceability. Metrological traceability means your measurements can be consistently and demonstrably related to national or international standards through an unbroken chain of comparisons, each with its own stated uncertainty. This foundational principle dramatically builds confidence in the integrity and reliability of your collected data. By integrating comprehensive drift correction directly into the calibration process, we proactively counter the inherent aging and environmental effects that impact sensors. This strategic approach ensures that the measurement data generated remains consistently accurate and dependable. Ultimately, this empowers reliable decision-making, safeguards the integrity of critical systems, and upholds the overall quality of results throughout the entire operational life of the sensor.